Okay, so I'm in the configuration tool here, and you'll notice that in my model view I have an empty model and a packaging. One of the things I want to do is demonstrate how we can use templates to create UDTs within Ignition. I'm going to build out a model of 8 fillers based on that template, and you will automatically see that generated in Ignition. Let's just pop over to Ignition. You'll notice that it is blank. We have no UDT definitions, and we have no MQTT nodes for flow. Right. So let's pop back over to Flow. If I come across to my templates, you'll see I've already generated a template. And what this is going to do within the definition of these items, tags and measures and things, I've already encoded a mechanism that Flow uses to auto-address through to the data sources. So if I look, for example, at a data source for my Flow historian, you'll notice that I have a tag naming standard which my template uses to auto-address. Okay, so let's go across and auto-generate this model. We're going to generate 8 instances. I'm going to name them uniquely from 1 to 8. And this is all encoded within the template. If I just quickly preview, I can see what's going to be generated. That looks good. I'm going to continue, and you'll start seeing in the model view this model is actually starting to be generated. All right, once that is completed, all I need to do is deploy this to the calculation engine. The integration engines will start picking it up. And what we'll start seeing almost straight away is data starts coming in to Ignition on the MQTT engine. There we go. We drill down to the flow nodes. Line 1, line 2, line 3, 4, 5, 6, 7, 8 have been auto-generated. I expect to see a UDT being defined, and that is based on the template that I have integrated on this side. What that now allows me to do, in fact, is to start seeing values come through. Here is, let's say, for example, under our energy, we should have an hourly value starting to come through. There we go. There's a value, and this is a measure value from which is a value for the period from 5 p.m. to 4 p.m. to 5 p.m. Okay, great. Now, what's more is what we've done, just as an example, is we've created a small dashboard that allows you to very quickly visualize those templates. So you'll notice we've got each of our lines and a bit of data. What's interesting though is that this data is sitting, these numbers are the numbers that are now sitting within tags within Ignition. But the spark line is actually an API call back to the flow API. So if we take that and we pop that into Ignition just as an out of interest, what you'll see is a whole lot of data being returned by our API. And we'll talk a little bit more about that later. Okay, great. I'm going to leave Ignition there. What you've witnessed here is a mass instantiation of 8 lines, 8 packaging lines, with a number of event frame definitions, measure definitions, tag definitions into our model. That could have been 100, that could have been 1,000. So yeah, what we hope to demonstrate here is the ability to massively scale out a flow model and quickly integrate it using open technologies, in this case MQTT Sparkplug, back in to other systems like Ignition. Okay, that's great. So now what I'm going to do is I'm going to take you through a little bit of how I actually built the template. I'm just going to take you through a couple of points, starting with an event frame. Okay, so first of all, what I'm going to do is I'm just going to create a folder within the model. Our model is very generic. It works on folder structure, hierarchical structure. You can use the structure to conform to an S95 or an S88 standard, or any standard that you would like. We've made it as flexible as possible for you. Okay. Flow allows you to connect in to a mass of different data sources. All right. Now I've already connected to a couple of data sources for this instance of Flow. And what I'm going to use for this build out is the Flow Historian, which is just a little simulator. I can drill down into the namespace of any of the data sources connected into my system. In this case, I get a folder and tag view. So you can see these are the tags that we've actually auto-addressed when we built out these lines here. What I want to talk about now is the concept of a tag within Flow, and through that I'm going to use the state tag. You'll see I've got a state tag in each of these fillers. What I'm going to do is create, I'm just going to work with filler 1 for this demo, so let's call it filler 01, and I'm going to drag a tag from my historian, from my data source that's connected to Flow. I'm going to drag it in to my model, and I'm going to abstract the name. I'm just going to call it state. I don't need to know what its tag name is in the data source. The link is already made, and Flow handles that in the back end. I don't have to worry about it. So let's see what that state tag looks like. What this little window is just a data source preview, so I can have a look at my data, look at the shape of the data, what the data represents. In this case, you'll notice a state pattern, a step number potentially for a sequencer for the fillers process. It starts at 0 where it's idle, moves up into a preparation or setup stage. It goes into production. It might have a few downtime events. It then goes into a CIP at the end of the run and then back to idle. So we're going to make use of this pattern when we build out an event frame shortly. Before we do that, let me bring in the product tag. We also have a product tag for each of our fillers. Drag the product tag in, also going to just abstract that name. Let's have a look at what that looks like. Again, this is just an integer value that represents the product that's being produced. So 1 might be apple, 2 might be lemon, etc., etc. Okay, and we're going to use that information when we build out our event and add some context to it. Great. So that is the next step. This little event icon allows us to build an event frame. I'm going to call this filler 1 batch. Let's just call it a batch. That's great. I'm going to open up the editor for this batch, and I need to define some triggers here. So I'm going to drag in a trigger. It's going to a tag. It's going to automatically create this trigger for me. I have various conditions that I can set. I'm literally going to set it when the state equals 10. I know that I'm going into a setup for my batch, and then I'm going to use the state tag again for my end trigger, and I know that when it equals 30, I go into my CIP state. So that's the end of my run. Great. What I'm then going to do is I'm going to add an attribute to this batch for each for each event frame, or batch in this case, that is produced. I'm going to link the product tag to this batch, the value of the product tag. And what's more is, I don't want to see it as an integer value. I want to enumerate that into a English description or a name for my product. So I've pre-configured an enumeration where 1 equals apple, 2 equals grape, etc., etc. All right, now we are going to deploy this configuration out to the calculation engine, the flow data and calculation engine, and very quickly we will start seeing some information coming through. So here we see a Boolean representation of when a batch, when an event frame was determined, start and stop. And further to that, for each of those, we've picked up what the product is and we've converted it into an English name. Great. Okay, the next thing I want to do is move on to tags. We've spoken a little bit about the state and product tag, but what I'm going to do now is I'm going to talk about some inputs to my filler. So let's go and create filler 01 inputs, and one of the things we want to do is we want to calculate energy. Our management has asked us to calculate the energy that is being used and the cost of that energy that is being used for our fillers, for our packaging lines. So you'll notice that if I hover over my data source namespace here, over the tags, I can actually see a description of these tags which is coming directly from the data source. So whether this is a Ignition historian, an Aviva Pi historian, a Canary, it doesn't matter. We bring through the unit of measure and the description of those tags. So I can have a look here. I've actually got a tag that represents the energy being used by the filler. So let's drag that across. Again, I'm going to abstract the name. You'll see it brings through the unit of measure for me. And let's go and have a look at what this looks like. Just quickly align it with the state tag and zoom out a little bit, and you'll just have give you an idea of, so while we idle, we're not counting. This is a counter or a totalizer of energy being used. Now, in itself, this number at the end here is not useful to me because I don't know where it started, how does it compare to the beginning of the day, maybe the beginning of the shift, the beginning of the hour. So what we're going to do now is we're actually going to manipulate that tag a little bit. We are going to, actually that comes a bit later, so don't worry about that. Let me just start that again. I wanted to make sure this is 01. Okay, so we're going to bring that tag across. this is our energy tag. I'm going to abstract the name, have a look at it. Great. How does that look compared to this one? Great. All right. So I'm going to bring in a couple of other tags. I've got a water supply, water. I have a product, the actual juice that is coming in. So you can see. Now, one of the ones that I want to show you very quickly is an interesting tag. I've called it the booster supply, water booster supply. So let's just have a look at this booster water. Let's go and have a look at the shape of this one. If I zoom out here a little bit more, just look at it over a couple of days, and I bring in the states just to overlay that, what you'll notice is there's a spike in this data. So I'm getting something funny from my flow meter here. I'm getting a spike in my data at some point during my production run. So I don't like that. That's going to mess with my calculations and aggregations. The other thing that I want to check is when I'm in an idle state, I should be seeing a 0 value for this flow rate, but I'm not. I'm seeing a slightly noisy signal when it should be 0. And I think that this is a fairly common problem. So what I want to do now is I want to take that value, that tag, and I want to do some data cleansing on it. And this is how I'm going to do this. Okay, let's drag it in here just to create some hierarchy. And what this allows me to do, it's a calculation which allows me to perform filtering, plus many other things. But in this case, I'm going to look at that value. If it is less than 0.1, let's say less than or equal to 0.1, then I'm going to rather use the value of 0. Okay. Otherwise, use that value. So let's just have a look at what that looks like now. Okay, putting it in against my state. When I'm idle, you'll notice that it's now gone down to 0. So I've pulled that noisy value down to 0. All right. However, I still have those spikes every now and then. So let's do one step further. Let's then say, hang on, when this value is greater than or equal to 15, then let's strip out that value completely. I don't want it to influence anything in subsequent downstream calculations. So I could, instead of null, maybe I could use a moving average of the last few periods. So I could do some manipulation there as well. For this example, let's just strip it out completely. All right, what's that going to look like? And let's pull the original in and then just go and have a look at that. And what you're going to start seeing is wherever I had the spikes, I've now replaced that with null values. So literally strip that dirty data out completely so that it's not going to impact anything further downstream. Okay, now what I want to do is a quick demonstration of another way of using the calculation capability. Let's create filler 1 production. Okay, and you'll notice I've got 2 bottle counts here. I'm going to use the good bottle count. So this is good production in a number of bottles. And I've also got reject. I'm going to call that bad production. So what if I wanted to do a quality calculation in the sense of OEE? I would want to do a ratio of good versus total, but I don't have the total. Obviously, the first thing I need to do here is to create a calculation, and that I'm going to call the total. This is an incredibly simple example, but just quickly shows you the capability of Flow. Let's drag in the bad, and literally all I need to do here is sum the two together. Great. Pull that out, and there we go. So that's an inline calculation. Now, what's quite interesting here is that in this case, in this example, I used a single data source, the Flow Historian, to pull the data in. But for whatever reason, I might have calculations where some of the data is coming from one data source, other data is coming from another data source, and I can pull those data sources together and do and blend them together in a calculation that spans across data sources. And it's such an easy process within Flow. All right, so now I'm going to move on to a concept of measures. Now, what we do within Flow is we slice the tag data by time or by event frames to create KPIs and certainly to do certain calculations that you cannot do with a point-based calculation. So let's do a couple of examples here. The first thing that I'm going to do is going to go back to what my managers asked me to do, and that is create a KPI relating to the energy that we've used, and more specifically the cost of that energy that we are using. So I'm going to go back to this energy tag that we created earlier, and what I'm going to do is I'm going to create an hourly measure. We call it an hourly measure. It's a KPI that gives you a value every single hour. I'm going to drag that onto the flow zone, onto the hourly icon. I'm actually going to call it hourly. I'm going to then open the editor, and I'm going to tell Flow that it must perform for every hour, it must perform a specific aggregation on that. Now, you might think that delta would be a really good way to slice that counter, that totalizer up into hourly values. Take the value at the end of the hour, subtract the value at the beginning of the hour, and you've got your total for the hour. And that's perfectly fine in this example of this totalizer. But as we all know in the OT world, is that totalizers often reset, they roll over, and so we have a better algorithm to use to handle multiple rollovers within a period, and that is called the counter retrieval. All right, you can even specify what your rollover value is if your meters are configured for specific rollovers, potentially a deadband. And I'm going to send that on to the calculation engine. And what's going to happen is that Flow is going to go back in time to this backfill date, September 1st. It's going to slice time into hourly periods. And then for each of those hours, it's going to go and calculate a value for that hourly measure. So if we bring that in here, let's just zoom out a little bit here. The top line is the original tag, raw tag counter, where that value is not very useful to me on a report, but this value, 5.32 kilowatts, is a really valuable measure on a report because I can see that's what I used in the last hour. What if I want to see it for the last shift? Okay, perfect. I drag the hourly onto the shift icon in the flow zone. And guess what? That shiftly value doesn't need to go back to the raw tag value and aggregate it for each shift. It knows that all it needs to do is sum up a number of hourly values which Flow has already calculated. So this makes the Flow calculation engine incredibly performant. You might ask me, well, how does it know what the shifts are? So let's go and have a look at that quickly. One of the things that you define within Flow is a calendar, or more than one calendar. A calendar can be used then to define things like, when does your year start? When does your week start? What time of day does your production day start? Here we're starting at 6 o'clock in the morning. Further to this, we can also specify shift patterns, right? So here we have a shift pattern. It's just a 3 by 8. And so because we've encoded this information into Flow already, the context of these measures or KPIs we're creating understands this. Now you'll ask, well, what if I run 2 lines on different shifts? That's great. You can create multiple calendars and you can provide different context to each measure or KPI that you create. Okay, now if we want to create a daily one, we can aggregate the day up, the shift up into a day, really as easy as that. Same principles apply. So let's have a look at what this all looks like. We've got our hourly, we've got our shiftly, we zoom out a bit, let's pull in our daily. Great. So you can see how quickly this data engine is running in the background. Excellent. Now our boss has asked us to represent this in a dollar format, an actual cost. So this is what I'm going to do. We've got an ERP system, which is a SQL database, and I'm going to hook Flow up to this ERP system. But something I want to just quickly show you is inside this ERP system, I've got this table called cost. Very simple. You can see over time here, the energy cost. This is every year the energy cost has gone up by an inflationary amount. But what Flow has done, Flow, when I've connected to it, has recognized this format, and it's actually structured this namespace as if it was looking at tags. So it's pulled out each of the columns data. So let's look at our energy here. And it's actually given us it's transformed that transactional data into a timeline of time series data. And that's just a little bit of magic that Flow does for you. So now, just like I did with the historian tags, I can pull this back across, and now I've got, let's have a look here. Let's go back 3 years, 4 years, and have a look. There's my data, and there's that inflationary increase over the 4 years. Now I'm going to use this cost per kilowatt hour tag to then go and create a value for my average, my time weighted average cost per hour, and I'm then going to create a calculation of that. Let's call that cost. Okay, that's going to be in dollars, and my calculation is going to be the cost per kilowatt hour multiplied by the kilowatt hours. Bang, and that's going to give me a value when I deploy that to the calculation engine of what my cost is per hour. Right. Next step that I want to do is I actually want to impress my boss, my manager. I want to do something a little bit more. I want to project this cost out into the future. So let's just show you very quickly what this would look like in a chart. So I have a chart here, pre-prepared. I'm going to just add that cost to here. Let's just rename this. That is my energy cost. Great. Let's just increase that, and let's put a label on here. Let's just do, I want the last value. There we go. Okay. Let's just open that up. All right, there's my cost each hour over time. But what if I want to see a totalized value each hour during the day? Okay, well, no problem. I'm going to do what we call a day-to-day calculation. Excellent. And I'm going to bring that into here. I remove this. That's not actually what I wanted. Okay. Let's do that. Let's do that. And let's put the last value on. There we go. Right. Go back to our chart. Refresh that. And now we can see how our total energy is progressing through the day. So we're currently at 2 p.m. Now what we want to do is we want to project to the end of the day. So let's go and build out this projection. What I'm going to do to calculate a projection is I'm going to take the cost, I'm going to do a 12-hour moving average or run rate calculation. So it's a 12-hour moving average calculation. Okay, just going to pop it under there, open the editor, and my calculation, I'm going to do something a little bit different to what I did before. I'm going to use I'm going to look at the previous range 12 hours ago, and then instead of looking at the current value, I'm going to get a bunch of values and calculate the average of those. Deploy that out. Great. So that's going to give me a moving average of my cost. So let's just pull that in. And then let's pull in the moving average. Make the moving average the thick line, and you can see how that 12-hour moving average has just smoothed that line out. So that's great. Now what I'm going to do is I'm going to project that moving average 24 hours into the future. Pretty straightforward. Projected. And there we go. This is what I'm going to do. 24 hours projected. And I'm going to retrieve the value at now. So I'm 24 hours ahead of time. I'm going to go back 24 hours to now. Okay, so that's 24. Great. And I need to remember to do my calculation. There we go. And run that. Okay. And that's going to give me a value projected 24 hours ahead of time. And then I'm going to do that same trick where I want a day-to-day value. There we go, and we deploy that out. And here we can see where I have projected that out into the future. Well, let's go and look at that. Here is the moving average. Here is the projected. So you can see the projected is literally projecting it forward in time, 24 hours. And then my day-to-date value of that comes through like that. So let's go and add that to our chart very quickly. And that is my energy cost projected. And let's make that dashed line, and let's add the last value. Okay, and have a look at that. Now we'll see where we're going to end up. Oh, I forgot to do something. I forgot to project my day-to-day value into the future. So let's just do that quickly. 24, bang. And now we should see when our data is finished calculating. There we go. So what we are projecting is that we're going to end up at 9.86 kilowatt hours for the day, which is great. And maybe just very quickly to show you, for example, if we were to add a regression, let's just do a plain linear regression to the actual where we are right now. Let's make that a dotted line, and it's going to be, and what you're going to notice is that there is a little bit of a difference here, and that is because the projected value is calculated based on a moving rate of 12 hours, run rate of 12 hours, whereas the regression line is only being calculated on what's in that chart right now. Okay, then the last thing we want to talk about is that all of this information that you have calculated and you've got running in the calculation, continuously running every time a period ends, calculations are done, aggregations are done, event frames are determined, etc., etc. Every time we do this, for all of this information is available either to our ignition system, it's available to other systems through various mechanisms. And one of those mechanisms is our public API. So if I come into our public API, I just want to quickly show you that. You'll notice that it offers a lot of information. So first of all, I want to just show you that there is a full metadata model. So you can search anything in that model to get information about the definition of events, folders, measures, tags, whatever it is that you're looking for. You can search for tag names in the search API and it will point you to things in the model. All right. With that now, you can go to the data side. You can then pull the data like I did previously inside Postman from any of your tags, no matter where those tags live, whichever historian or data source database they live in, you can pull that information from those tags through the Flow Public API, and it will return all of that data to you in a common format. You can also see information around the configuration of certain items within the flow configuration, things like calendars and shift patterns, and you can even create shift patterns through the Flow API. All right, and that pretty much ends it off for me. Thank you very much.